Hello, welcome to Math with Mr. Dobrescu to the rescue. Today we are going to find quotients of powers, and we are going to use inductive reasoning after looking at some patterns in order for us to come up with a formula and simplify our exponents. Take a look at this one here. We have 2 to the 4th power divided by 2 to the 2nd power. What does that really mean? If we do the extended form, the repeated multiplication form, okay? If we do the repeated multiplication form, how many 2's do we have on the top? 2 to the power of 4 means 2 times 2 times 2 times 2, 4 times. So on the top we have 2 times 2 times 2 times 2, 4 times. And on the bottom we have 2 times 2. 2 times 2. And now we see that we can simplify 2 2's from the top and 2 2's from the bottom. So we can simplify these 2 and these 2 on the bottom, these 2 on the top and these 2 on the bottom. And now we are left over with 2 times 2, or we can say 2 to the 2nd power. Let's take a look now at the second example. Here we have negative 4 to the 5th power. It means negative 4 times negative 4 times negative 4 times negative 4 5 times, right? So we have negative 4 times negative 4 times negative 4 times negative 4 and times negative 4. And on the bottom here we have negative 4 times negative 4. Negative 4 and times negative 4. And again, we see that we can simplify 2 negative 4's from the top and 2 negative 4's from the bottom. They simplify out. And we are left over with negative 4 times negative 4 times negative 4. Or we can say in a power form, negative 4 to the power of 3. Okay? Let's take a look at another example. Here we have 7 to the power of 7. It means 7 times 7 times 7, 7 times, right? So we have 7 times 7 times 7 times 7 times 7 times 7 and times 7. 3, 6, 7. And on the bottom we have 7 times 7 times 7. 7 times 7 times 7. And again we can see that we can simplify 3 7 from the top and 3 7 from the bottom. So 1 from the top, 1 from the bottom, and so forth. And we are left over with 7 times 7 times 7 times 7. Or we can say 7 to the 4th power. And now I'm going to give you some time to work on the other examples. Take about a few minutes, work on the other examples, and then let's see if we can come up with a general rule using inductive reasoning. We are looking at this pattern of these patterns, and we can see if we can come up with a formula so we can do a shortcut, okay, from this to this, a shortcut, okay? Take a few minutes, you can pause the video, work on these examples, and then come back, and let's see what's going to happen if we come back. Welcome back. Let's take a look here. We see that we had the base is 2, exponent is 4, and on the bottom we divided by 2, the same base on the bottom, but the exponent was 2. So we see that in this case, our answer was 2 to the 2nd power. So here we had 4 on the top and 2 on the bottom for the exponents. And if we subtract 4 minus 2, we get the 2 right there in our answer. The same thing here. We have negative 4 to the 5th power and negative 4 to the 2nd power. And if we subtract the exponents, 5 minus 3, 5 minus 2 becomes 3. The same thing. The same thing for this example, 7 to the 7th power divided by 7 to the 3rd power. If we subtract 7 minus 3, we get the 4. So now, after you did all these examples, and after we use the inductive reasoning and looking at those patterns, we can come to a conclusion in general terms that if we have a base raised a to the power of m divided by a to another power of n, we can say, because we have the same base, we can write the base only once, but then we can subtract the exponent. So the answer would be a to the power of m minus n, and this is in general terms. We can use this formula now, since we came up with the formula by using inductive reasoning. We can use that formula in order for us to get to solve some examples. And take a look at our examples here. The first example here, we have 2 to the 6th power divided by 2 to the 4th power. And again, if we use this formula, since we have the same base, which is 2, we can simply subtract the exponents. So we have 6 minus 4, 6 minus 4, 2 stays as the base, and 6 minus 4 becomes 2. So the answer is 2 to the power of 2. Okay, we use this formula now, the formula we came up with by inductive reasoning, and we came to this answer. Let's take a look at B now. We have negative 7 to the power of 9 divided by negative 7 to the power of 3. The same thing, the base is negative 7. And here in this case, we subtract the exponents again, 9 minus 3. 9 minus 3, and then we get negative 7 as a base to the power of 6. And finally, we have h to the power of 7 divided by h to the power of 6. The base is h. And the same thing, we are going to subtract the exponents. 7 minus 6, and 7 minus 6 becomes 1. So the final answer would be h to the power of 1, or we can just say h, because h to the power of 1 is still h. Okay? So that's it. We used this formula, a to the power of m minus n. We subtracted the exponents, and we got the answer. Let's take a look at this type of example. Here we have to simplify this expression. So we have 3 to the 4th power times 3 to the 2nd power divided by 3 to the 3rd power. And let me do it with you guys using two different forms, two different modalities. The first one, we can use the extended form. So if we use the extended form here, we have 3 4s times 2 more 3s, 4 3s, and another 2 3s. So altogether we have 6 3s. So 3 times 3 times 3 times 3 times 3 and times 3. And on the bottom we have 3 times 3 times 3. 3 times 3 and times 3. And now if we simplify it, we can cancel, or simplify rather, 3 3s from the top and 3 3s from the bottom, and we end up with 3 times 3 times 3, or we can say 3 to the power of 3. This is the extended form. But now if we use the formulas we came up with, first of all, we can use the formula from a few days ago. If we have this, if we multiply two numbers, if two numbers have the same base but different exponent, and if we multiply it, here we can just add the exponents. So on the top, for the numerator, we can say we have 3 to the power of 4 plus 2 first, 4 plus 2 over 3 to the power of 3. And we know that 4 plus 2 is 6, so on the top we have 3 to the power of 6 over 3 to the power of 3. And now we can use the formula we learned today. In this case, we are subtracting the exponents, right? This formula, a to the power of m minus n. We do the same thing here. We are going to subtract, the base stays the same, 3 to the power of 6 minus 3. And the final answer, of course, is 3 to the power of 3. You see, we got the same answers, right? So on a test, if you get this problem and they're asking you to simplify the expression, you can use either of these modalities, either of these forms for you guys to get the answer. So it doesn't matter which form you use. You can use the extended form, or you can use the formula here, the shortcut. You just need to get the answer. So if you got the answer 3 to the 3rd power, you're right, and then you move on to the next question. Let's continue with our last example here. So here we have simplifying expression. So we have a to the power of 10 times a to the power of 7 divided by a to the power of 6 and times a to the power of 4. And again, if we do the extended form here, we have 10 a's and another 7 a's. We have 17 a's, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? 17 a's on the top. And on the bottom we have 6 plus 4, 10, right? So we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we can see again that we can simplify 10 a's from the top with 10 a's from the bottom, right? So we simplify these. Okay, and see what we are going to be left over with. So now if we count, we have 1, 2, 3, 4, 5, 6, 7. So now we have a to the power of 7 as our final answer. And this is the extended form. if you forget the formulas, you can always use the extended form and get the answer. Okay? And now let's take a look here using the formulas we've learned so far. So on the top here we have the same base. We multiply the same base but different exponents. And in this case we can keep the base and add the exponents. 10 plus 7. And we can do the same thing on the bottom. We have the same base, which is still a. And then we are adding the exponents. 6 plus 4. And see what we get. So this is the first formula. If we have the same basis, we are just adding the exponents. And now let's see, on the top here we have a to the power of 17. A to the power of 17 over a to the power of 10. And now we are going to use the formula for today. If we divide two exponents, right, two bases that have different exponents, we can keep the base, which is a, and just simply subtract the exponents. That's 17 minus 10, which is a to the power of 7. And you see, we got the same answers. Again, thank you so much for watching, and I appreciate you paying attention to these examples today. Again, if we have two different bases, but if we have different exponents, right? In this case, we use the inductive reasoning, and in this case, we subtracted the exponents in order for us to get to the answer. Again, thank you so much, and I'll see you in the next video, and please don't forget to like and subscribe. All the best to you.